Hi everyone, so today we're going to look at the multiplayer add-on, and we're going to look at the changes that I've made to it so it's much more user-friendly and a lot more powerful. So since the last video there's been a number of changes. Let's look at an example game first. So we start the client and the server, and on the right hand side we have a client and on the left we have the server. Now the way this is currently functioning is the client on the right is sending its information to the server, and the server is then applying that to the state management system and broadcasting it to the other clients. This isn't ideal. In ideal terms, we would actually have the server running the logic, but this is the simple answer for now, before I actually implement a more generic movement system. So in terms of how this is actually functioning, the actual add-on has changed quite a lot since we last looked at it. So we still have RPC calls and properties and so on. The order of the properties is now conserved in the arguments panel and in the replicated attributes panel. And if you change data on these properties, for example the type, all of the existing network data will remain. So you can change the argument type, and the replication statement here is still true, even though we changed the variable type. So that's a bug fix. Arguments again can be selected per function call, and the interesting thing is this network state panel. We now have a nice UI for selecting states, and you can still apply the states as you wish before. The simulated states panel is used to enable states to be marked as simulated. If they're not marked as simulated, then those states will only be allowed to be run if the object is either an authority or is a simulated proxy with a simulated marker. And that's explained better in my other network tutorials. We got rid of the buttons. Now you can actually click on each state to view it directly. What else has changed? The template system has also had a lot of modifications done to it. Now it actually shows you the base class that we're using, which in this case is the SCA actuator class. And you'll notice that there's no option to enable it because it's a default class. In the bottom here we have this thing called template attributes. This refers to the final class that is produced after combining all of the templates together. And these are all the attributes available to that class. So if we go and include a pawn or a projectile, the projectile doesn't actually add anything new, neither does the weapon attachment, but the pawn does. The pawn adds this floor offset variable. And what's more, if we change the maximum floor difference squared to 58, if we disable this pawn, it goes back to its default value of 4. So you can basically see the final attributes on the class in this panel. This is quite useful for changing defaults. If you disable use networking, the entire network stack disappears. And if you disable networking in the if you change your net mode from server to client, then the attributes panel is grayed out. So if you go back to server, you'll see it pops back into color again. So those are a lot of the changes. Let's look at a little bit about how we actually got that demo to function. So first things first, on the dispatcher, on the client state, which is what we're currently looking at now, just to show you, we have this connection.connect function, and that connects to the server. If we go to the server state in the dispatcher, it'll actually apply the server rules, and I've mentioned this before, but the reason that this can work is because we've enabled use networking, even though it's not a network object per se. Now, if we go to layer 2 and select this cube and set the client state, you'll see that what we have is an always sensor driving a number of logic bricks. Firstly, we're driving this movement.keyboard function, which basically moves the object around using the keyboard presses. So you'll see here that's what that does. And then we have orientation.right and position.right. And all that does is it writes the current position and orientation to 3 properties: rotx, roty, rotz, and then posx, posy, and posz, respectively. And that enables us to then use the replication system to send these over to the server. And we actually do that by invoking the RPC client position to server message, and that will then trigger the RPC call in question. So because we've bundled these arguments with these RPC calls and they're being sent to the server will get copies of these posx, posy, and posz variables and so on when these messages are invoked. If we go to the server state, when we receive those messages, we then apply position and apply the orientation by running the module position.read and orientation.read. And this is where the server then mimics what the client is doing locally. The server then actually broadcasts its position using physics because it's physics enabled, and that's part of the built-in system, which is where this replicate simulated physics come from. If we disabled this, then any connected clients would not receive any simulated physics. So that's basically it for now. Things I need to add include the ability to change the network roles on an object and to support better the movement system. Thank you guys for listening, and I'll keep you posted.